All right, so this is part 2 of 7.3 solving trig functions. So yesterday we did 9, but we left off with 10. This is the one that if you look at it, you see that there are 2 trig functions, right? That's something that should be alarming right from the get-go because that means you're not solving it the normal way. These 2 trig functions are both part of one of your Pythagorean identities. Again, something you want to recognize. And that is that tangent squared plus 1 equals secant squared. So I have to change one of these. And this time we actually have choices. You can change either of them. Where the last example, you could only change the squared one. I can only plug in for sine squared there. This time you can plug in for either. I would say there's pros and cons to both sides. If you're solving for secant, then when you get to the end, you're going to have to do the reciprocal to get to cosine, which is fine. You can still do that. If you solve for tangent, you already know your tangent. So maybe I would do that one, but honestly, it doesn't matter, okay? So if I want to replace secant with what it equals, I already know the tangent squared plus 1's on that side. So I can do 2 times tangent squared x plus 1 minus 2 tan squared x minus 4 equals 0.
Ours is, well, mine is different. It has a 3 at the beginning.
This is 3 on yours, so it's 3. Then I would, thank you for catching that. Then I would distribute and I would get 3 tan squared x plus 3 minus 2 tan squared x minus 4 equals 0. I want to combine my like terms, so I would combine the 2 tan squareds. 3 tangent squared x minus 2 tangent squared x is tangent squared x. And positive 3 and negative 4 is negative 1. And then I would add the 1. Tan squared x equals 1, and then I would square root. And when you square root, you're doing plus and minus. So I'm looking for where tangent is positive or negative 1, which is where? Where's tan 1? What's the denominator? 4. So because it's tangent, we only pick from the top, right? I would pick the 2 in the top because it's positive and negative. So positive 1 would be my pi over 4. And then negative 1 would be at the 3 pi over 4. And then to this, we add the n pi. Yeah.
You can also like break it up, right? You get like tan plus 1.
Oh, like factor it? Sure. Yep. Was that your question? Yeah. You wouldn't be able to do it if it was like a 3. So just keep that in mind. You would move it to the other side and you'd square root it and you'd get plus or minus root 3, which is an answer. But you wouldn't be able to factor if it was 3 because 3 is not a perfect square. But absolutely, if it's a perfect square, you could do it. All right, then we get to ones like these. So this, 2 things to notice here. One is the directions actually change, and it says to solve on the interval of 0 to 2 pi. When it says that, you don't have to add the n pi or the 2n pi. And you pick everything that's on your natural unit circle. That's an answer. So for tangent, we wouldn't just restrict it to the top. We would use the whole circle, and then sine and cosine, we use the whole circle like we normally do. If 0 is an answer, we include 0 because it has a bracket, but we do not list 2 pi because that has a parenthesis. So parenthesis says go up to that number, but don't include that number, okay? The other thing is, these are very different how we're about to do them, and so because we do them a specific way, we have to check for extraneous roots, which means we have to take the answers, we have to plug them back in. Sometimes they may not work, okay? So the reason that these are different is because if you look at it as is, you obviously cannot solve it. There are 2 different trig functions there, and they are not squared, right? So I can't use my Pythagorean identities. Does that make sense? So we square them so that they can be used in their Pythagorean identities. So I'm going to square both sides of this equation. On the left, that means cosine x plus 1 times cosine squared plus 1. Do not distribute the exponent. And then it equals sine squared x. On the left, I'm going to FOIL it out. I would get cosine squared x plus cosine x plus cosine x plus 1, or cosine squared x plus 2 cosine x plus 1 equals sine squared x. Yeah.
On the homework, like the ones that you told us to skip, these were the ones that you told us not to skip.
I did?
Yeah.
Oh, I'm sorry. If it was not squared and they were different, you should have skipped it. Yeah, so if you got confused, that's why. Sorry. All right, so now I've got two trig functions, but there's a squared for the second one, right? So I can replace sine squared with what it equals in my Pythagorean identity. So sine squared plus cosine squared equals 1. That means I can replace sine squared with 1 minus cosine squared. So cosine squared x plus 2 cosine x plus 1 equals 1 minus cosine squared x. Now I've got them all to be one trig function. There are squareds and non-squareds. I want to group them together. So if I add the cosine squared x to both sides, I end up with 2 cosine squared x plus 2 cosine x, and then I would subtract this 1, and it's actually going to cancel. I get equals 0. If it was 3 terms, I'd factor the trinomial. Because it's only 2 terms and they both have a cosine, I can actually take the cosine out. And it would be 2 cosine x plus, actually I get to get a 2 cosine. And then it's cosine, you could do it either way, it won't matter. 2 cosine, then it would be cosine x plus 1 equals 0. And then we split and solve. So divide by 2 here, cosine x equals 0. Subtract the 1 here, cosine x equals negative 1.
In the beginning, can you also do like before you make the sign? Before you add the 1 minus 1 plus cosine to each side, can you just do the a squared plus a minus?
Can you substitute it in? As long as they are all cosine. So not when they're still, you mean from this step?
Yeah.
Yeah, sure. After you replace the sign, so they're all the same trig function, absolutely. Yeah. Okay, so then if I were to go to my unit circle, and I'd use the natural unit circle because it says 0 to 2 pi, so I don't have to add on any increments, I would look around for where my x is 0. So where's the x 0? At pi over 2. 3 pi over 2, and where's it negative 1? Pi. Good. So, as of now, the answers are pi over 2, pi, and 3 pi over 2. Now, when you change your equation by squaring it on both sides, you have to check for extraneous roots. So now I'm going to go back to my original equation, and I'm going to plug in these answers. I'm going to say cosine of pi over 2 plus 1 equals sine of pi over 2. I'm going to solve that. Then I'm going to do cosine of pi plus 1 equals sine of pi. I'm going to solve that. And then I'm going to do cosine of 3 pi over 2 plus 1 equals sine of 3 pi over 2. If the left side doesn't equal the right side, then it's extraneous root. I cancel it out. Okay? So we just, yeah, so because it's not, we didn't just use substitution, we didn't just factor it. We physically changed this equation by squaring both sides. That's the only time you have to test for an extraneous root. But because we did so, we actually changed the value here. So we have to make sure what we got still works. So I'm going to take every answer that I've got, and I'm going to plug it back into the x of my original. So because there's 3, we're doing it 3 times. And when we get done with these, we're going to make sure the left side equals the right. If it doesn't, it's an extraneous root, we literally cross it out. So cosine at pi over 2 is the x at the top, right, which is 0. So this would be 0 plus 1 equals, and sine at pi over 2 is 1, and I get 1 equals 1. So this one works. You could do this with any of your questions, by the way. You could plug them back in and make sure they work. The only ones you have to check are the ones you square both sides. All right, then I go cosine pi plus 1 equals sine pi. So at pi, my x is negative 1 plus 1. And my sine at pi is 0. And I get 0 equals 0, so it works. And then the third one, cosine 3 pi over 2, that's 0 plus 1 equals sine 3 pi over 2. And that's negative 1. Which means this answer does not work. So I cancel out the 3 pi over 2. And I only include the other 2 as solutions. All right, we're going to do it again with 12. So again, notice they are not squared. There's no substitution possible here, and I can't solve because there's two different trig functions. So I'm going to square both sides of the equation. This becomes sine of x plus 1 times sine of x plus 1 equals cosine squared of x. When I FOIL that out, I end up with sine squared x plus sine x plus sine x plus 1 sine squared x plus 2 sine x plus 1 equals cosine squared x. With me so far? All right, then I know I got to replace. I'm not going to replace the sine squared because then there's still a sine. So I want to replace the cosine squared. If sine squared plus cosine squared equals 1, then cosine squared would equal 1 minus sine squared. So this stays sine squared x plus 2 sine x plus 1 equals 1 minus sine squared x. I'm going to move everything to one side, so I subtract the 1 and add the sine squared x. 2 sine squared x plus 2 sine x, 1's cancel, equals 0. Take out a 2 sine, and I get sine x plus 1 equals 0. Split and solve it. Sine x would equal 0. Sine x would equal -1. I would go to the unit circle. I would find where the y is 0, which is at 0 and pi. And where the y is -1, which is 3 pi over 2. Then I check them. So I'm going to plug them back into the original. So sine of 0 plus 1 equals cosine of 0. Sine of pi plus 1 equals cosine of pi. And sine of 3 pi over 2 plus 1 equals cosine 3 pi over 2. Sine at 0 is 0. Cosine at 0 is 1. So that one works. Sine at pi is 0. Cosine at pi is -1. So that one does not work. And sine at 3 pi over 2 is -1. Plus 1, and cosine at 3 pi over 2 is 0. So that one works. So the 2 I keep are 0 and 3 pi over 2. All right, so then we move into these kind. These kind are called multiple angle ones. So like if you're the type of person that tries to find, videos or extra practice on your own when you're searching for trig equations, these are called multiple angle equations, okay? So the reason that they are different, and you want to spot it, is that there is something attached to the variable in between the trig function, that variable. So this is not just 2 cosine of t minus 1 equals 0. It has a 3t there, okay? So the first thing we're going to do is actually isolate the trig function. So we're going to get cosine of 3t by itself. We're then going to find the angle answers like you would normally do. But it's not x that equals that. It's 3x or 3t in this case that equals that. So you've got an added step of dividing everything by what's next to it, okay? So these have like one extra step at the end. You want to catch it when you're looking. Like when you're looking through the homework today, every time that there is something attached to the variable, that's one of your multiple angles, and you know you have an extra step on those, okay? So first I'm going to solve it, right? So I'm going to isolate the cosine of 3t. This you have to isolate together. So I'd add the 1. 2 cosine 3t equals 1. Divide both sides by 2. Cosine of 3t equals 1/2. Now you go to your unit circle and you find everywhere where cosine is a positive 1/2. Cosine is positive on the right side of your trig of your unit circle, right? And the x is 1/2 where? Pi over 3 and 5 pi over 3. So normally my answer would be pi over 3 plus 2n pi and 5 pi over 3 plus 2n pi. And normally this is just a single variable. So it would have said t equals or x equals that and I'd be done. But this time it says 3t equals that. So I have to divide, and when I do, I have to change both the angle and the interval. So both parts of those answers get divided by 3. So this would be like multiplying by 1/3, and this would be pi over 9 plus 2n pi over 3, or 2/3 n pi. So not only does that multiple angle thing that's attached to the variable change your answer for the angle, it also changes the increment. So it's important you wait until after you've added on the interval to then divide by whatever's next to it.
Wait, so we have to multiply by 1/3 and like.
Well, dividing by 3 is the same as multiplying by 1/3. So this is the same as that.
Oh, so
But you have to change both the angle and the interval. So then on the other side, I divide by 3 or multiply by 1/3 here. And I get t is equal to 5 pi over 9 plus 2n pi over 3. So those two angles are the answers.
And we don't have to find extraneous roots.
No, because we didn't square both sides. So only if you square both sides. All right, 14, you're going to add the root 3. 2 sine 2t equals root 3. Divide both sides by 2. Sine of 2t equals root 3. So now you're looking for where your sine is positive root 3, which happens where? 2 pi over 3 and pi over 3 plus 2n pi plus 2n pi. And then the last step would be to divide both sides by 2. So multiply by 1/2 here, divide by 2. Multiply by 1/2 here, divide by 2. Pi over 6 plus n pi and 2, well, this cancels, and pi over 3 plus n pi. And those are your two answers. So the only variation on this, I would say, is that sometimes it's not just multiplication in there. Like if it had said 2 sine t over 2 minus root 3 equals 0, it's still a multiple angle one. There's still something attached to your variable. So I would have solved it. Sine t over 2 equals root 3 over 2. I would have found the answers for those angles, which were what, pi over 3 and 2 pi over 3 plus 2n pi plus 2n pi. And instead of dividing by 2, this time we'd have to do what? Multiply by 2. So those are still multiple angles, even though you're not multiplying in here. Sometimes you'll see division, but it's any time that the variable has something other than a squared attached to it. So if it's being multiplied or it's being divided.
If it was just t, it would be the same, right?
It'd be like you're done here in the purple. Yep, normal. You just got to look for when it's got a number attached to it. All right, and these, well, there's one more. Last one, I'm not even going to torture you with, okay? Because what happens here is, let's just say, we'll start it. So I would say a squared minus 3a minus 2 equals 0. Is that factorable? There is no factor of -2 that adds to -3. If it was +2, sure. then it would work, right? But if it's -2, there is none. So how would you solve this? Quadratic formula. So the purpose of this question was just to review the quadratic formula. So let's do that part, but then we're going to stop. So -b plus and minus the square root of, I'm going to write it off to the side because this is important. -b plus and minus the square root of b squared minus 4ac all over 2a. So -3 plus and minus the square root of 3 squared minus 4 times a times -2 over 2 times a.
Wait, isn't b -3
Today.
be positive?
Oh, yeah, this, sorry, I wrote it there. This is there, that's there, thank you. So 3 plus and minus the square root of 9 plus 8 over 2 gives you 3 plus and minus the square root of 17 over 2. So without a calculator, you would have to approximate this. Like this would be like a 4.1, let's say, because it's just slightly bigger than 16. But what happens is I'd get 3 plus 4.1 over 2 and 3 minus 4.1 over 2, 7.1 over 2, which is 3.5 something, and negative 1.1 over 2, which would be negative 0.5, and it continues, right? So in both of these scenarios, you cannot use your unit circle. If you had a calculator, you could do the bottom one. You can't do the top one because the top one is too big. Sign can't be bigger than 1. You could do the bottom one, but you'd have to have a calculator. And it just won't happen on your quiz. Like, you're not going to have a calculator. It would all be unit circle based, okay? So this is a no solution for the 3.5. If that was my only answer, it's no solution. The bottom, it's not that there's no solution. It's just you would need a calculator, okay, which you don't have. So the purpose of this question would be to just review quadratic formula. You are not going to have one that's not factorable. You'll be able to factor it. Yeah. On the homework, there's none with the quadratic. These you can skip on the homework because they're duplicates of the notes. What did I say? 5? Like, you'll get to an answer. It will say tangent of theta equals a number, and that number is not on one of your tangents, so you'll know. Yeah.